been there, you may imagine it's going to be big, tall structures, possibly, which you're monitoring. So, now it's you're ready. The turn is yours. Here's also a microphone.
I think this will be fine.
You take this one? Okay.
If I need to, yeah, thanks. All right, well, thank you for the opportunity. I will be demonstrating this, the ADNEC Capital Gate Leading Tower of Abu Dhabi SHM system. My name is Mauricio Sudarregal, and I am a program manager for the SHM and nuclear power plants monitoring systems at Kinemetrics. I'm going to get the demo going while I continue talking about the project. Let me get the system started, and hopefully I will come back when the demo is up and running. Well, the project itself, what the ADNEC SHM system is part of, is the Abu Dhabi Municipality's seismic hazard and risk assessment project that Kinemetrics Open Systems and Services carry out in the years of 2011 to 2013. One of the 20 different tasks that we carry out as part of this project was the implementation of state-of-the-art integrated SHM systems, and one of the structures was the ADNEC Capital Gate. This is just a little flavor of the interesting structures that are being built there in Abu Dhabi. These are 5 of the buildings instrumented in Abu Dhabi City, and as part of them is the Capital Gate. The ADNEC SHM system consists of 25 epicenter accelerometers, triaxial and uniaxial sensors, wind sensor, ultrasonic wind sensor for speed and direction of the wind, as well as one central data acquisition system, one GPS antenna for time synchronization, and one PC rack for continuous processing of the data. This slide here shows the distribution of the sensors. We had obviously wind sensor and GPS on top of the tower, and we go from one of the basements all the way up, instrumenting different levels, typical floor plans. As you can see, this structure represented a particular challenge because at the same time that it's leaning, I don't have a plant view here, also the plant is rotating. So it was quite a challenge to define sensor orientations and else. Here is a picture of a typical system configuration where we have sensors throughout the structure, which are wired, connected to a data acquisition system, and dedicated computer to process the data. The SHM system front end obviously is not the sensors, it's not the hardware itself, but this software that we had to develop to characterize the structure, in particular dynamic characteristics, as well as some responses. And the final result of the SHM system is to determine interstory drift, and then compare to 3 different performance levels upon the occurrence of an event. Here we have an example of analysis done right after the events in Iran that affected these structures. I mean, the farther the earthquakes, you only get surface waves, and these tall buildings are affected by this type of events. Here we see that here is the graphic of the interstory drift plotted against these three different levels of performance. Immediate occupancy, which is the green color, yellow, which is life safety, or inspection is required, and collapse prevention, which is the red. Even though the shaking was quite strong, the interstory drift didn't pass the immediate occupancy alarm level. So I'm going to move on to the actual, if I can. Here we have, something happened. Here we are. Sorry. What I did is, instead of showing you ambient vibration being recorded and you know, wiggles from that, I feed 3 cycles of these Iran earthquakes, so you can see how the system is processing this data. We have signals coming in, but these are total model displacement time series. We also follow and check or track changes in the time domain for the model frequencies and the model damping ratios. And of course, I mean, we have animation of I don't have it animated here, but we have animation of the model shape. I think my time is over. And then the purpose of the entire project is to provide the tenants of the structure a rapid assessment of what is the condition of their structure upon the occurrence of an event, either earthquakes or wind event, which is also common in that particular part of the world. Well, thank you very much, and stop by the booth if you have any questions. Thanks.